Akashic is a memory service for long-running language model agents. Across 4 workloads and 3 model sizes, it reports up to 1.88 times higher sustainable request rate than the memory baselines in the paper. The key problem is not only which memories are relevant, is where those memories sit on storage. A retriever may choose just a few useful chunks, but if they're scattered across many SSD pages, the physical read remains slow. The paper calls this the locality gap. MemAttention starts by dividing the interaction into bounded chunks. Each session keeps one append-only active chunk. With the paper's default setting, compaction triggers at 1024 tokens, so a maintenance step rewrites one bounded unit instead of the entire history. Chunking alone can preserve stale or contradictory facts. When the gate fires, the model compares the new chunk's metadata with earlier chunks and selects the 5 most relevant ones. It reasons over them jointly, allowing old memories to be updated, refined, or removed. At inference time, the current query is matched against chunk metadata using the same model-driven relevance rule. The top 5 chunks are fetched, restored to chronological order, and combined with the current context. Akashic then records which chunks are used together and relocates strongly associated chunks into nearby physical blocks. It writes new copies out of place, marks old copies invalid, and lets a background garbage collector reclaim them later. On LocoMO, the locality experiment cuts blocks touched per request from 6.8 to 3.4, and cold cache P95 retrieval latency from 38 to 22 milliseconds. Across the full evaluation, the largest sustainable request rate gain is 1.88 times. The reusable lesson is that agent memory needs 2 designs, a logical policy for what to remember and a physical policy for where to store it. The reported prototype uses Qwen 8 billion, OPT 30 billion, and Llama 70 billion on H800 servers with NVMe storage. Distributed deployment remains future work.